So in our previous section, we looked at the univariate unconstrained optimization, but now we're going to extend this to the multivariate domain. And what I mean by that is we either want to find the maximum or the minimum of a two-dimensional function all the way up to any n-dimensional functions. And in general, we can split this up into two methods, and that is the direct method and the gradient method. Okay, so the direct method is beneficial because it doesn't require the calculation of gradients or derivatives. And an example would be the random search method and the univariate pattern search method. We'll cover the univariate pattern search method at the end of this section. And the gradient method obviously requires the derivative, and examples of this are the steepest ascent or descent method. So now the direct method of the random search is fairly inefficient because it is brute force, and so let's just make a note of that. It's brute force, inefficient, and it's simplistic. But it does have the advantage that it will find the location of the maximum or minimum in a global sense and not a local sense. And this is quite important. And also it can be applied to discontinuous and non-differential functions. Again, this is a benefit of it. So what is the random search method? Well, if we're given a domain such that x is within a lower and upper bound and y is within some lower bound and upper bound, we would then use a random number generator to generate a large number of sample pairs, so xi and yi. And we would use these pairs to locate the maximum or minimum of a function. So graphically, that would mean if I had a function, and I'm going to draw the two-dimensional contours here. It looks something like this. My random number generator would generate a number of pairs of x and y coordinates within this domain. Remember, my domain is x lower bound and x upper bound, y lower bound and y upper bound. I could then use these pairs to find the optimal solution, which would be somewhere here. But again, as I mentioned, this is brute force and it is rather simplistic.